So the next question is a your turn one. So if you would like to try it on your own, then pause the video and have a go at it. And we are going to graph an original function of y equals x squared minus 7x plus 10 and its reciprocal, and then fill out the chart, which is at the bottom of your page. Okay, so let's start with y equals x squared minus 7x plus 10. And so that will be our starting point. So we will graph y equals x squared minus 7x plus 10. Let's start with our x-intercepts, where y equals 0, so plug in 0 for y. Now this quadratic is factorable, so we will factor for the x-intercepts, and we get that x equals 5 and x equals 2. Then we will get our vertex. We'll use our vertex formula, negative b over 2a, and from the function you can see that b is negative 7, so let's substitute in negative 7 for b, and a is 1, so substitute in 1, and you get 7 over 2, which is 3.5. Find the y value for our vertex by plugging into the original equation. And we get that y is equal to negative 2.25. Okay, so we have a vertex at 3.5 and negative 2.25. So let's graph our original function then. Our vertex at 3.5 and negative 2.25, around there. So 3.5 and negative 2.25. We have a x-intercept at 5 and an x-intercept at 2. Alright, and so we graph that in. And here is y equals x squared minus 7x plus 10. Alright, so now we're going to draw the reciprocal function. So reciprocal function. Okay, so we will start with the vertical and horizontal asymptotes. Alright, so our vertical asymptotes are at the x-intercepts of our original function, so that is where x equals 5 and x equals 2. And we will also draw in our horizontal asymptote, which will be at y equals 0. Okay, so we have a vertical asymptote where x equals 2, and remember to label them. Okay, you should always label vertical and horizontal asymptotes on your graph. Okay, now we're going to take a look at graphing the relative, in this case maximum. Okay, so from our original function, we have a minimum at 3.5 and negative 2.25. So on our reciprocal function, we will have a relative maximum at 3.5. And remember, to get the y-coordinate, we find the reciprocal of our y-coordinate on our original function, and that would be 1 over negative 2.25, which will give us negative 0.4, and so we have a relative maximum at 3.5 and negative 0.4. So that would be about here. Okay, and we will label that 3.5 and negative 0.4. All right, now the next thing that we will graph will be our invariant points. Now, you don't have to give me the exact points for that because we're just sketching. So what we do know is that they happen where y equals 1 and y equals -1. So what you want to do, you want to run your pencil along the line y equals 1, which is a horizontal line that goes through y equals 1. Wherever the blue graph and y equals 1 meets, as you have an invariant point. So we have one here. And we keep moving across the graph because we have a second one right here. Okay? And then we want to go to where y equals -1, which is a horizontal line going through y equals -1. And we'll do the same thing. Wherever the blue graph crosses that line, we will put a point. Okay, and notice 2 of them. So you will have for this graph anyway, 4 invariant points. All right, and then what we do is we graph the reciprocal function. Okay, keeping in mind 2 things. One, that we want opposite behavior. And 2, glide along asymptotes. Okay, so let's graph that in. All right, let's start underneath the x-axis. We have a original function that is a parabola opening up, so our reciprocal function will open down. And remember, keep the top of the function somewhat flat. And remember to glide along your asymptotes. Okay, above the x-axis, remember opposite behavior. So if we have y values here that are getting larger and larger and larger, then on this side of the invariant point, we're going to have y values that will get progressively smaller and smaller and smaller, and they will glide along the horizontal asymptote. If you take a look at the points for y which are on the left of our invariant point, they're very small values for y, so opposite behavior means that on our reciprocal graph, our y values will get increasingly bigger and bigger. Okay, and we have the same thing going on the other side of our left vertical asymptote. So we glide along horizontal asymptote and glide along the vertical asymptote. And there is your reciprocal function. Y equals 1 over x squared minus 7x plus 10. All right, so let's fill in the chart below. Our original function is y equals x squared minus 7x plus 10. Reciprocal function is y equals 1 over x squared minus 7x plus 10. All right, domain for regular parabolas is all real numbers. Our range is determined by our vertex. Our lowest point is -2.25. So y will be greater than and equal to -2.25. Our x-intercepts are at 2 and 5, and our y-intercept is at 10. And remember, you can get that by substituting in x is 0 into the original function. And you get y equals 10. Okay, for our reciprocal function, our domain is all real numbers except for our x values which are on the vertical asymptote. So x cannot be 2 and x cannot be 5. And note that they are the x-intercepts of our original function. Okay, our range is split up into 2 parts, the part which is above the x-axis and the part that's below. In this case, above the x-axis, y is greater than 0. Below the x-axis, okay, it's tied into your relative maximum, which is at -0.4, and so y is greater than and equal to negative 0.4. Sorry, less than and equal to negative 0.4, right? Because you want all those numbers which are less than this. Okay, do we have any x-intercepts on our reciprocal function? No, so none. Do we have vertical asymptotes? Yes, we have one at x equals 2 and one at x equals 5. And once again, they are tied into our domain restriction and our x-intercepts of our original function. Okay, y-intercepts. Well, you could plug in 0 for x, but if you take a look, the y-intercept on our original function is 10, so the y-intercept on our reciprocal function is the reciprocal of that, so 1 over 10, which is 0.1. And if you go up to the graph, you can see that that is true. If you go over here, it's pretty close to 0.1. Okay. And then our horizontal asymptote is where y equals 0. And we are now finished graphing the reciprocal of quadratic functions.